Let's have a look at exercise 552. Here we have the graph of the derivative of different functions here. Here we have the graph of the derivative of f. And as I said in class, by looking at the graph of derivative, we can say a lot about the function itself. So first here, we're going to look at this graph, the derivative of f, and use this to find maximum or minimum points to the function f, right? And the thing is, if the derivative is equals to 0, then the function has either a minimum, maximum, or terrasse point, right? And we see here that the derivative is equals to 0 when x is equals to 1. So when x is equals to 1, the function f, which you can't see, we can just see the derivative, but we then know that the graph of f has either a minimum, maximum, or a terrasse point when x is equals to 1. And we should also be able to find out which of these it is. And we see that just before 1, the derivative is negative, minus 2, minus 1, and so on. And this means that f, which I of course can't see here, but I know that f then has to decrease like this, all the way up to 1 o'clock. And then the derivative is 0, which means that f stops decreasing. And then the derivative is positive. It's first minimum, negative and then positive. And when the derivative is positive, we know that f is increasing. So this means that f has a minimum point. So the answer on this first question here is that f has a minimum point when x is equals to 1. That's the answer. And here we have the graph of the derivative of g of x. And we see here that g of x, the derivative, is 0 when x is equals to 2. So we know that g either has a minimum, maximum, or terrasse point when x is equals to 2. And we see that the derivative is first positive, then it is negative, which means that g of x is first increasing and then decreasing. So this means that we have a maximum point. So g has a maximum point when x is equals to 2. So that was what this exercise is all about, and you can try on P and Q on your own.